So you've heard one talk about some physics experiments. What is physics doing here in the gathering for Gardner? I hope it'll become apparent by the end. Let me have 30 seconds of introduction of who or what I am. Why am I talking to a bunch of mathematicians, magicians, and puzzlers? The real puzzle in life is physics. Mathematics is just the language of the puzzle. And most of the puzzles you have actually with physical objects. And this will be about a real physics puzzle. Also, a remark about what am I doing this kind of stuff for? In real life, I'm an astrophysicist, but in my old age, I'm becoming a half astrophysicist. The pseudosphere uphill roller is the title of the talk. What is the uphill roller? How many of you have played with an uphill roller? Did you do it in, how many were forced to do it in high school physics? How many actually did it in a nice museum like the Exploratorium? How many never saw this before and don't know what I'm talking about? It's a mixed audience. So let me introduce the uphill roller, the classic uphill roller. This is a version of one that's in the Galileo Museum in Florence. It's a demonstration of physics devised by an obscure mathematician named William Leyburn, not long before Newton published the Principia in 1694. So this is a demo that's been around for 300 years. What could you possibly have to say that's new about it? In the original version, the idea was that you have a double ramp and a double cone, and the double cone seems to roll up the double ramp, violating the laws of physics. Here is William Leyburn. Here's the original publication, so if you want to see how it was written up in the very beginning, Recreations, this is about mathematical recreations, a mechanical paradox, or a new and diverting experiment, whereby a heavy body foul by its own weight move up a sloping afkent. They didn't know how to speak English. Anyway, and you see the basic idea here. It's a little hard to see in projection because the sloping end is coming up, and we'll try to show it here, and then I'll show a video as well, but we'll do the real one in a moment. So you get the idea. There are some rods here. They're sloping up towards the bottom of the picture. And now can we switch now to Elmo? Elmo. Elmo. Thank you. So here is this uphill roller. It's a little hard for you to see in the back. There are some tilted rods. Just to prove you they're tilted down to the right, we're not doing stuff with smoke and mirror or rice. So this is a physics demo, not by a physicist, not mathematician. Different kinds of materials roll down. But now we put on it the double cone, and it rolls uphill. So think about that for a moment. It's 1694. Just understand, Newton barely understood momentum conservation. Do you know that angular momentum was not conserved at that time, nor energy? It took 200 more years. So this was mighty mysterious. It was not only a recreation, but a puzzling demonstration. So we'll come back and play with the real one. Can we switch back to the computer for a moment? It's been 300 years since the demo was devised. Here is a display case. Who is from Coimbra here? Yes. This is in your physics department. I don't know if you've ever gone and played with it, but I was delighted to see they're the same, and this is 100 years after Portugal had one of the greatest collections of physics demonstration apparatus, still does. That's 100 years later. Ooh, this is what you go buy from a physics supply house today. The demo has stayed the same for about 300 years. More beautiful examples I've stumbled on in art museums, science museums, exhibits. These are ones from the art museums in Munich last summer. What does this have to do with the gathering for Gardner? Martin Gardner seems to have been very taken by this demonstration. He wrote about it on several occasions. He called it the anti-gravity cone. Did anybody read the New York Times reports this week about the anti-gravity cone? Anybody read the New York Times at all about inflation? All the news that fits, we print. Inflation is an idea that sets the universe going using anti-gravity, laid to Alan Guth, but it's been around for a couple hundred years. So Martin Gardner wrote a nice piece. It was published in several different articles, but being Martin Gardner, he wasn't happy just to publish the standard one, so he came up with an awfully nice variant that mixes up many of the things that people, of course, enjoy here: cards, mathematics, physics, ping pong balls. Can we switch back to the Elmo? Elmo, thank you. So here's Martin Gardner's variant on it. It's not really his, but the variant itself is his. Deck of cards, sleeves, nothing up sleeves. And what he suggested was, well, substitute for the double cone a ball. Well, let me do it this way first. You can't quite tell which way these are going just looking up there, but they are going downhill. So that's the downhill direction, not upside down, right side up. Anyway, downhill direction. But if you open it up this way, the ball rolls uphill. How many of you have been frustrated as hell with the toy that's based on this? So here's a very nice variant that Martin Gardner published, not in a math magazine, by the way, in the Physics Teacher, for physics teachers. So you can all make this for yourselves. The solution to this uphill roller problem, it's not violating the laws of physics, it's not anti-gravity, it's in fact the proper gravity. In fact, the center of mass is moving down as the double cone moves up. The solution to the problem depends on three angles: the angle that defines the cone, and the two angles involved in the separation of the two rods and their elevation. It involves a little more, but this relationship between the three angles, by and large, gives you the solution for when the double cone will roll uphill. But when I had seen the one in Florence a year and a half ago, I got so enamored of it, I asked a woodworker who was a wonderful person, Randy Ryan, to make me a nice version, just like they have in Florence. I wanted one. And I designed some ones, and they're upstairs to play with. I'll talk about it in a minute in the exhibit hall. So this thing was on my mind just as how to design an optimal one that works very well. And separately, I was thinking about pseudospheres. What the hell do pseudospheres have to do with this uphill roller? Absolutely nothing at all. The pseudospheres had to do with, I'm an astrophysicist, I was trying to make objects that students could play with to understand what an open geometry is about. Saddle surfaces, other surfaces, but a pseudosphere is a very nice example of an open surface. These two subjects have nothing to do with each other on the face of it, but I had my one Kekulé moment in life. So if we can switch back to Elmo. Elmo. Let me show you the real Elmo here. So here is our uphill roller apparatus. Here is a pseudosphere. I want people to make a prediction. Will the thing roll up? Will it roll down? Will it stand still? Will it be viscous, non-viscous? Just kidding. Have I rigged this up with something? So how many say it rolls uphill? How many paid attention to the title of the talk? How many downhill? Yes, you have two hands up. Why is that? Both directions. Let's take a look. So what this is the first new variant on this demonstration in 300 years. Don't applaud, because one of you is going to have to figure out the solution that I just showed before for this. How do you calculate where it's going to stop, what the oscillation frequency is, and so forth? I haven't sat down and done it yet. But you don't have to do that. Go upstairs. This set of little objects is sitting up there. made by Randy Ryan. And play with it for yourself. I'd love to chat with people about it. I hope one of the mathematicians in here is hooked enough to want to do the full solution of this. I'm too old for that. Thank you very much.